Now I'm pleased to call to the stage Andy Christensen.
Thank you, Mandy, and thank you to the IFT team for organizing these presentations. And thank you for taking the time to be here today. My name is Andy Christensen. I'm the Business Development Manager for Bepex International. And my goal today is to take you through one of our approaches around drying, where we're able to really open up some new opportunities in terms of product quality and efficiencies in the drying process. Now, before I dive in, hey, real quick, is there a clicker? Okay, thank you. Before I dive in, I want to tell you just a little bit about Bepex, in case you haven't worked with us before. So at Bepex, we've been around for over 100 years and have worked in the food space the entire time. One of the really unique things about Bepex is the sheer volume of technologies we offer and work with. We group those technologies under a few main categories. So, drying and thermal treatments, agglomeration and particle formation, size reduction and homogenization, including grinding and milling. So what kind of projects do we do at Bepex? Well, we love using our range of technologies to focus on product development. Whether it's something completely unique to the market or it's your unique version of a product you want to introduce, we love involving our team and really working on the process to meet those product goals. Another thing we work on with companies is if you have a batch system and want to increase production and move to a continuous process. If you're tolling, want more control over your process and bring things in-house, we do a lot of work with that. And valorization of waste streams. Upcycling, minimizing waste, turning waste streams into revenue-making assets is a huge project that we like working on with companies. And the other area we do a lot of work in is companies have kind of dated drying systems, or maybe they've worked well over the last 30, 40, 50 years, but for whatever reason, they don't quite meet the full scope of what's needed today, whether ingredient demands have changed or they want to increase production or just move forward with different operational goals. So at Bepex, we've worked with a lot of these companies on either replacing, expanding, or just designing new ways to approach their systems. Now, one of the scenarios we've had to work with companies is companies that have, say, wet feed material drying systems. And in these drying systems, they may be using steam tube dryers or spray dryers, and however they work out, they're coming to us with some concerns, and these are common concerns with drying, but with these systems specifically, they're concerned about, hey, gosh, we're using a lot of utilities, or we have a tremendous amount of heat involved or attention to the different heaters. If we're using natural gas, hey, we're concerned about carbon footprint and emissions. Might be worried about airflow and all the exhaust involved with that. And then, of course, the footprint involved with drying systems, massive footprints, and the housing to hold these footprints, it takes a lot of space. If you're building expansion, the square footage and the height is really something to contend with and can be expensive. So at Bepex, over the years, working on drying projects and working in the industry, we really wanted to work to move the needle on some of these concerns. So what we did is we worked on developing a new drying system, a new approach to drying, that really works on these concerns and offers something different to our customers. So let's get into it. At Bepex, we developed the PCX Dispersion Flash Dryer. Now this is a compact, small footprint dryer that really does well with a wide range of feed materials. So it goes from dilute slurries all the way to thicker, higher viscosity feeds, cakes, non-pumpable wet cakes. Now it's a direct flash dryer, which means the hot air stream comes into direct contact with the material and the material dries quickly. Now flash drying is not a new concept. The key to the PCX is that it's a dispersion dryer, and here's how that works. The material comes in through one port, the hot air stream comes down through another port simultaneously. Material mixes over the dispersion plates. As it mixes over those dispersion plates, material spreads out, creating more surface area, and we get an even, consistent evaporative drying effect. The other unique feature we designed into the inside of the drying machine is the ability for the PCX to manipulate particle size. How that works is as the material moves across the dispersion plates, depending on how we design the dispersion plates and configure them, the plate tips, the design of the liner, the clearances, and the overall rotational speed of those dispersion plates, we can control the particle size. So with the PCX, we can dry and mill a wide range of different feed materials in a small unit. Okay, so I want to show you real briefly what the kind of system flow looks like. So the air goes into the air heater. Now, in this example, we're going to use natural gas. You can use hot oil, steam, or electric, and a lot of customers nowadays are electing for electric to save on the carbon footprint and emissions. The airstream drives the material through the unit. As it goes through the unit, it comes out at the desired particle size, the desired final moisture, and collects into a cyclone or bag house. The water-laden airstream then separates out and gets expelled out into the system. Okay, so I want to show you a real-world application that's running right now with the PCX. So a customer brought a challenge to us. They're running a successful product, but they had a waste stream. And this waste stream was a vegetable pumice that was really challenging to move through a system. It was a fibrous material. It didn't flow well, but they knew they had a valuable product if they could dry it and mill it down to the specifications they needed. So the waste stream was about 14,000 pounds an hour. So this is a significant waste stream. 90% moisture. So now, forgive me, I'm going to round my math a little bit for stage math, but about 12,500 pounds of water and 1,500 pounds of solid in that material. The customer wanted the PCX configured, if it could do it, to produce two very distinct products. One is a coarse material they wanted to use in animal feed, and the second is a finer particle size, lighter color, higher value product that they wanted to use in human nutrition. Well, the PCX was able to handle the material well, bring the moisture down to 8% solids, and they had the option to run either product they wanted at the desired particle size. Okay, so what I want to do is show you what this looks like from the system standpoint. So we have our 90%, 14,000 pounds, 90% moisture material going through the system, 8% moisture dry solids coming out. Here's the metrics of what this system looks like. So square footage is 4,000 square feet by 50 feet high. Now this is, maybe a little smaller than your average drying system. It's still a significant amount of space, and this includes the bag house, the heater, the unit, the fresh air intake, everything with the system. For capital investment, we're just using a base cost, starting cost of 1x, and the airflow is 64,000 CFM with 21 million BTU per hour. So that's the energy that's going into the system. By all standards, we had success with the customer, right? The customer was looking for a system that could handle that material, could produce the particle size they wanted, and get down to the final moisture, shelf-stable moisture they wanted. So it was a success. But Bepex, we knew we could take this one step further. We wanted to take this one step further. So what do we know about the PCX? Well, we know it handles high viscosity materials really well. So what we did is we added our screw press in front of the dryer. So now we have our 90% wet feed material coming out as 83% and then going into the dryer. Now, while that percentage looks pretty small, it's not as linear as it would suggest. Going down to 83% moisture actually took out about 6,000 pounds of water per hour. So if you remember, we had 14,000 pounds, 12,500 was water. Now we're down to 6,500 pounds of water, and now that's moving through the dryer. Look what that does to our data now. So now because we have much less water to dry off, we have a smaller system, right? So now the square footage has gone down, smaller system, less expensive to build, less investment to get the system. Drying off half the water, we now have half the airflow and less than half of the BTUs involved. So just mechanically removing a lot of that water before the more expensive thermal step made a huge difference in what we're able to do with this system. We wanted to take it one step further. So at this stage of the design, what we did is we added an exhaust air recirculation system to the exhaust of the PCX. So, and what that does is it takes a portion of that steam-laden exhaust air and reroutes it back in front of the heater to the system. And this does a few things for us. So the first is now, instead of just ambient air, I should say we were running about 80% recirculated air in this with 20% fresh intake air. So what that does for us is that, one, with the heater, we now have warm air moving through the heater. So it's warmer air than ambient temperature, so the heater doesn't have to work as hard to get the air up to temperature because we're starting from a warmer spot going into the heater. The second thing that does for us is that water-laden air moving through the system allows the system to run mostly inert, right? The oxygen content is extremely low because the gas pushes that out. So now we can run a hotter inlet temp, create more drying in a smaller unit. And that steam, what it does is it serves as a protective envelope or a protective blanket, if you will, over the product so it doesn't damage or degrade the proteins, the fibers, the starches, in this case, the vegetable pumice, as it moves through the system. Now, it's really important whenever we run like this with a recirculation system, that we understand the limiting oxygen concentration. We do not want anything to combust. We want to make sure we're running with two tenets in mind. One, we always have to run safe, and two, we cannot denature or damage the product in any way. But incorporating that change to the design, look what happens to our system, right? So now, once again, because we're able to dry off less water, our square footage has gone down. It's no longer nearly as big of a system, right? Smaller system overall. Even with inserting the screw press, even with inserting the recirculation system, it is now a much less expensive system to get into. Look what happens to our airflow, right? Now we're recirculating most of that airflow, so just a fraction is now actually being expelled out. Now this is particularly important if you need to treat the exhaust, if you have particulate matter you're concerned about. There's much less of that to be concerned about and monitor and work with when your exhaust looks like that. And then even though we're running a hotter inlet temp, because that warm air is significantly more so than ambient air, overall the heater's working less hard and we're using much less BTU to accomplish the drying that we need to do. And all this is still within about 8% final moisture, getting the particle size, and meeting all the product quality demands the customer had. Now we've applied this technique and this approach of dewatering and really embracing a higher solids content to find more efficiencies with other materials too. And I want to show you three super quick. So the first one is yeast. Now, same thing, they were using a spray dryer at 95% moisture to dry yeast. They wanted to expand, add another line. So we worked with them. So we used the concept of mechanically separating some of that water. So there's the cake that went into the dryer. Now we have a twin screw feeder that's basically more robust than your standard feeders to make sure those cakes consistently feed the dryer. Well, we were able to bring that inlet moisture down, run more efficiently, dry to the particle size, shelf stable 5%, and just some incredible savings in overall utilities and emissions. Next, we have a fermented corn protein. Same process with this, right? We separated out some of the water in front of the system. We're able to concentrate the material. We could take that mash then, move it through the dryer. Again, keeping our temperatures down, right? Even though we're running a hotter inlet, the product temp is not coming up. In this case, the product temp did not exceed 160 degrees because if we denature the protein, it's just not gonna work, right? So we're able to achieve the color, the particle size, the protein level that they wanted with that, again, while massively bringing down utilities, emissions, the overall footprint of the system. And the last example I want to show you is we worked with the soy fiber. Again, they were, I think, a steam tube dryer they were using for this. We inserted our screw press, took that moisture down in front of the dryer, able to dry to the particle size they want, huge savings. Now, prior to this, they were using this in animal feed applications. Because in the dryer, we could save that extra milling step, get the product quality to a human nutrition quality product. They were able to then turn this into both an animal feed application and a much higher value human nutrition application. And this kind of application, we've tested and installed in many different scenarios, and it's really just the tip of the iceberg of some of the things we're doing at Bepex. So we've worked on this system with over 12 different plant-based proteins, alternative proteins. We've worked with starch and fiber byproducts, and then we've used our our technology, especially with starch, to then modify RVA profiles and do starch modification downstream for different functionality. We've worked with fermentation byproducts, spent grains, a wide variety of different products to really find some different efficiencies and different options to how to approach drying. Now the PCX is one dryer. At Bepex, we've got 9. So, and then when you incorporate all of our other technologies, we offer 26 different technologies. So as I mentioned earlier, the new product development, companies love working with us because we take the ideas and the goals and we vet everything through our process development center. And usually how our process works is a company will approach us, we talk about some goals, we can dive in and do some real small scale bench testing, small scale equipment runs, and then jump into some larger scale pilot testing where we really get the scale up data we need, fine tune the operation and the process, and really achieve the product and particles that we want to achieve. So. Okay, before I wrap up here today, I do have a tool that all of you can use. So as we work on projects with customers, high level, they're often asking, what are some of the savings we could get if we used a system like this or system X or system Y? We'd like to get to this point. What's possible? Well, as we developed the PCX, we also developed kind of an energy savings worksheet, if you will. And what this workbook does is it allows you to kind of punch in some information about your desired rates, utilities, different goals with your process, and it helps calculate a few scenarios of what's possible high level with some of your energy savings. Now, in full transparency, this is a bit of a complicated worksheet, so my recommendation is scan the QR code, we'll send you an email, you download it, it's your worksheet, we don't have access to it at that point, but my recommendation is work on it with us. So we've got some engineers here that you can meet with after this, we've got the worksheet at our booth, and we'd love to have you go through it because sometimes the savings are pretty substantial and it's really neat to see what's possible. So we're at booth 3847, so if you don't want to download and just want to come check it out, if you want to see any of our technologies, we have information on all of them there. We even have some engineers here, so if you want to just high level talk about basic feasibility or what's possible, we're happy to go through that with you. Really appreciate your time and hope this gives you at least another option or kind of tool in your toolbox when you look at your own production and drawing options. Thank you.